Okay, it says let blood alcohol percentage values F of WD be given in the body of the following chart, where W stands for body weight in pounds and D stands for drinks consumed in less than 1 hour. Estimate the partial derivative of F with respect to D, that's the number of drinks, right? At 140, 3, using the table. All right. So what would, if we had a formula, what would the exact value of the partial of F with respect to D, generically, what would that look like? What would the exact value look like if we had a formula for it? Okay, so the limit as delta D approaches 0 of what? F of W, comma, D plus W. Is it D plus W? Delta W? Delta D. Okay, and then minus F of WD, that looks good now, and then all over delta D. Does everybody agree with that? Okay. Well, we don't have a formula for F, right? So taking the limits kind of out the window. But we can get an approximation. So let's adjust this formula. Let's erase the limit, and we'll use a wavy equal sign here and say that that's approximately the value. And then let's go ahead and plug in the weight and drink numbers. So it would be 140 for the weight, and number of drinks 3 would be approximately, okay, how does this change then? F of 140 comma, well, okay, hold on just a second. 3 plus, you're not wrong, but 3 plus delta D, okay, minus F of 140, 3 all over delta D. Everybody with me? Just plugging in the particular values of W and D that we're given. Now, you're going to want to look, as far as figuring out what delta D, the change in D is, you're going to have to work with what's given here. How is D, the number of drinks, changing? By 1, right? So the best we're going to be able to do is estimate this 2 different ways, by letting delta D be positive 1 and letting delta D be negative 1, and then averaging those values we get when finding the difference quotient. Okay? So let's do that then. So for, let me scroll down just a little bit. Let me do it for delta D equals positive 1 to start. So again, we're just going to fill in this formula. What would this second formula give us? 140, well, 140 comma 3 on the left side, and then we've got F of 140, and then what would this become? Somebody already said it. 4, and then minus F of 140, 3 all over 1, right? So I'm not going to write that down. Okay, so look at the table. What's F of 144? 0.107? Okay. And then what's an F of 140 comma 3? 0.08. And then what do you get if you subtract those? 0.027. Okay, I didn't hear the 7 part. 0.027. Does everybody buy that? Okay. Any questions so far? Does that seem reasonable to you? Then what do we do? So just so I can hopefully do it all on one screen, let me shrink this down, bring it up here. Now let's do delta D. So this is an estimate all on its own, but it's not it's not in the answers. I'll show you how I got the answer. So delta D equals negative 1. So how does that change things? How does that change the difference quotient right there? So it's still on the left side, we're still estimating, and really it's an estimate, right? The partial with respect to D, when the weight is 140, number of drinks is 3, but if we add in -1 here, this first guy becomes f of 140, comma 2 minus f of 143. That's still going to be 0.08, right? This guy. And then all over, this time I'll put it in, delta D is -1. Everybody okay with that? Okay, what is f, according to the chart, what is f of 142? 0.054 minus 0.08, and then take the opposite of it, divided by -1. Do I have confirmation on that, mission control? 0.026. Okay? So then what did I do to get the answer that I gave you? Just average those together. So what does the average of these two numbers turn out to be? 0.0265. And, okay, that's all you had to do in part A, right? Because I had you put down the units in part B. Does that make sense? Okay. But I think it's worthwhile to talk about the units because that helps with understanding here. So this would be the answer in part A. Let me see if I can make some room here. And then part B, okay, let me write down that estimate again. And what are the units for that? Okay, let's give everybody a reminder of the notation we use in Leibniz form, Leibniz notation, because that can lead you to the correct units if you're not sure. So if we're calling FZ, right, Z equals F of WD, then in Leibniz notation, we're saying this is approximately equal to what? The partial of Z, we're using Z here. You could use F if you want. Partial of Z with respect to D. And I like that notation because it reminds us to think of a derivative, whether it's a partial derivative or a regular derivative, as a rate of change, right? Or kind of like a slope. A slope is a rate of change. And the units of slope would be rise units over run units. Okay, so what's the function value? If you forget, it'd be F would be blood alcohol percentage, right? Right? So how do you want to write that? So blood BA percent? Okay, I like that. Blood alcohol percent. This is informal, right? Okay, over what? Number of drinks. So part C, interpret the meaning then. So what does 0.0265 mean in this case about the blood alcohol percent and the number of drinks? Is it increasing or decreasing? Okay.
For a person weighing 140 pounds.
Okay, so maybe I'll type this out. I like the way you started that. Because it's not much relevance for a person weighing 200 pounds, right? So for someone who weighs 140 pounds and consumes how many drinks? 3 drinks. Okay, what's happening?
It'll increase by 0.0265 for every additional drink.
Okay, so the his or her, let's say it's a him, his blood alcohol percent is increasing by 0.0265%. Yeah, I like that. Let's put in about. By about 0.0265% per. What would you say after that?
For each additional drink.
I would just say per, yeah, but per drink, that's what that means, yeah. Per drink. So let's proofread it, make sure I didn't make a mistake. For someone who weighs 140 pounds and consumes 3 drinks, his or her really, blood alcohol percent, I mean, actually, that might not be accurate, right? It might be different for male and female, so we're being a little loose here. But it doesn't specify, yeah. For someone who weighs 140 pounds and consumes 3 drinks, his or her blood alcohol percent is increasing by about 0.0265% per drink. I don't know if that's accurate or not. It's just a problem. I got that table off the internet. Might not be accurate, but it was a problem that I could use to illustrate how to find numerically approximate a derivative. That number seems low to me,